Hello, everyone. All right, we're ready to rock and roll here. Hopefully, everybody is keeping themselves safe and healthy. We start with new material. Okay, I sent packets home a couple weeks ago. This is chapter 7 packet. All right, we'll do a little bit at a time. Hopefully, you have all read the email on how this is going to progress and you understand how you will be graded. If there's any questions as to how you will be graded or anything at all, shoot me an email, okay, so we can figure it out. You should also have joined the Google Classroom. Some of you have not. And of course, you're on Edpuzzle because you're watching this video, okay? So keep up with everything so you can get your stats credit for college now. If you don't, you will jeopardize getting the credit. And this is college credit, so it goes on your transcript and will stay with you wherever you go to school. Okay, so and if you need your book, some of you have already made arrangements to get to school and get your book. You'll need to get your book from school. Call school and go get your book. Okay, I'll show pictures or whatever, but if you want to look up answers in the back and look at the sections in a little more in depth, then you want to get your book. Okay, so here we go. This is 7-1, Introduction to Hypothesis Testing. So we're going to do it step by step. We're going to do it kind of slow, just because this is new to all of us, okay, without me physically being there to help you out. So what our hypothesis test is, the process that uses sample statistics to test a claim about the value of a population parameter, okay? So you're taking samples, okay, and then comparing it and stuff you already know, testing a claim about it, okay, a population parameter, something that's already happened. Medicine, psychology, business, you can really use it anywhere. We'll see a lot of different examples. So our first example, this would be example 1, okay? Example number 1, okay? Suppose an automobile manufacturer advertises that its new hybrid car has a mean mileage of 50 miles per gallon. If you suspect that this mean mileage is not 50 miles per gallon, how could you 50 miles per gallon? How could you show that the advertisement is false? Okay, so this is something you're testing. Now, it's a 5-step process. So we're going to start and look at each individual step. And it's going to seem, pretty obsolete when you start it. But when you put everything together, it will make sense. Okay, so when we state the hypothesis, okay, so stating the hypothesis, this is step 1. Okay, like I said, when we get into the next section, after I just explain every single step, we put them all together. Everything is organized. Okay, so your null hypothesis. It's the statement being tested in a significance test. The significance test is designed to assess the strength of the evidence against the null hypothesis. Usually, the null hypothesis is a statement of no effect, no difference, or no change from historical values. The abbreviation to the null hypothesis is H0. Okay, that's the abbreviation. Now, the inequality symbols, okay, we have to use inequality symbols, okay? Equal to, less than or equal to, greater than or equal to. So the null hypothesis has some sort of equal to in it. That's how you know it's the null hypothesis, okay? Now, the alternate hypothesis is the claim about the population that we're trying to find evidence for. And that abbreviation is HA. That's the alternate hypothesis. And what that does, that represents all other possible values it could be that are not included in the null hypothesis. So they often use not equal to, less than, or greater than. So there is no equal to in there. So what it says here, it says write both hypotheses of exercise 1. Okay, so we go back to look at exercise 1. Okay, and it says the automobile manufacturer, and here we go. Now the claim, we suspect that the mean mileage is not 50 miles per gallon. Okay, so you have to identify the claim. Okay, so for step 1, okay, the claim is the mean is not 50 miles per gallon. Okay, So the claim, mu is not equal to 50. So what you have to do now is you have to represent everything that it can be. Okay, so if mu does not equal 50, so that could be 51, 52, 53, 49, 48, 47, all the other values, come on now, all the other values would just be m equals 50. So that represents every single value that is possible. Okay, so once we have that, we then have to identify our null and alternate hypothesis. Now, these are the two choices. Okay, the null hypothesis, if you look above at the notes, it says that often uses equal to, less than or equal to, or greater than or equal to. So mu equal to 50. Okay, therefore the alternate hypothesis would be the other one, which is not equal to 50. And you have to make sure you show which one is the claim, because you're going to need that when you get further on in the steps. Okay, all right, now the next part is filling in a table. So you see the verbal statement about the null hypothesis, mathematical symbols, verbal statements. This just helps you with inequalities, picking out inequalities. So here they are. So these are the ones from the book that you want to pause the video and copy these down. So the verbal statement, these are the statements that you might see in the reading. Okay, so the null hypothesis. So what does it mean? Greater than or equal to k. So mu is greater than or equal to k. Okay, verbal statement for the alternate, less than k. So the alternate, mu is less than k, below k, fewer than k. So these are just possible choices that you have. Okay, so like I said, pause the video. Okay, copy these in your notes. Okay. All right, so here we go with more examples. All right, so hypothesis always refers to some population, not to a particular outcome. Be sure to state the null and alternate hypothesis in terms of the population parameter. Okay, so the population parameter, remember, is the mean or the standard deviation. So write the claim and state the null and alternate hypothesis. So what we'll do is we'll underline the claim. Okay, so the consumer analyst reports that the mean life, so this is key, the mean life of a certain type of automobile is not 74 months. So this is similar to the previous one. So step one, the claim is you're talking about the mean is not 74 months. Okay, now how do you represent every other possible outcome you could have? Mu equals 74. So like I said, it's very similar to example one that we just did. So now we identify what the null and alternate hypothesis are. So it's mean and mean. Remember, the null hypothesis has the equal sign. So mu equals 74. Mu does not equal 74 would be your alternate. And the claim is does not equal 74. That's step one. That's all there is for step one. Okay? Then we use that for step 2, step 3, and so on and so forth. Okay? Now this says variance, but we change it to mean because remember, stats 1, we focus on mean and standard deviation. A television manufacturer publishes that the mean of a certain life of a certain type of television, so here's your claim, is less than or equal to 3.5. Okay, step 1, the claim, and again it's the mean, is less than or equal to 3.5. Okay, so less than or equal to 3.5, 3.5, 3.4, 3.2. So this is where the table comes into place. If you are confused as to what symbol you use, you look this up. Where's less than or equal to? Oh, okay, and that's the symbol that I use. Now, all of the values are greater than 3.5. Okay, so now you have your null and alternate hypothesis. Okay, your null hypothesis has the equal to. Okay, remember, equal to, less than or equal to, or greater than or equal to. So we have mu is less than or equal to 3.5, and then everything else, mu is greater than 3.5. And the claim, in this case, is the null hypothesis. Okay? And then the last one, a radio station publicizes that its proportion of local listening audiences is greater than 39%. So the claim is greater than 39%. Oh, what am I doing here? 1. Okay, the claim. And we're talking about proportion. Okay, so that's the population parameter. So this is a p instead of a mu. Okay, similar to the last chapter, we dealt with mu's, and then we dealt with the p for the point estimate. Okay, so p is greater than 0.39. All right, all other values possible are p is less than or equal to 0.39. So then you have your null and alternate hypothesis. So remember, the null hypothesis is anyone that has equal to. So p is less than or equal to 0.39, okay, and p is greater than 0.39, which is your claim. Okay, so that is, let's see what we got on the next page. I think that's it, though. Okay, yeah, that's as far as we need to go, okay, for your step one. Okay, so what I want to do is I want to show you a couple more examples from the book. Okay, here are some examples from the book. Okay, where it says a university publicizes that the proportion of graduated in 4 years is 0.82. Okay, so these are three that you can read and look at the examples. Okay, now what I'd like you to do, the work. All right, so the work that is due on, well, hopefully Tuesday. Tuesday they should be done, and then Wednesday we have a new lesson. Okay, so you have this page right here, which I don't know what page it is in the book, but 9 through 17 odd. Okay, I don't know if I can even write on this. No, see, I can't write on this. So 9 through 17 odd here, and then on this page 23 through 27 odd. Okay, these answers will be posted either late Monday or early Tuesday or later Tuesday. Who knows? Okay. So you have to check them. So remember, you have to show that you watched the video, and then you have to show that you checked your answers on Edpuzzle. These technically aren't due till Thursday, all right, to get your full credit. Okay. If you don't watch them, you don't get the credit. Okay. So, that's it, I believe. Okay. This is Monday, so we'll have a new lesson on Wednesday. Okay, and then some more practice problems on Wednesday into Thursday. Thursday we have office hours at 2 o'clock. I'm going to try to set it up on Google Meet. I don't know how well it's going to work, but we'll try it. And then Friday is a hand-in assignment. Okay, that what I'll do is I'll give them to you at the end of the notes, or the answers to the notes on Thursday. Okay, so you have them. All right. Okay, everybody. Take care.